Hey everybody, welcome back. Mrs. Calabrese here. Welcome to Unit 7, Lesson 2, your second lesson of 6th grade math online. Very exciting. It was really great to see all of the work that you submitted yesterday, and I'm so excited to dive into today's lesson. Just a reminder that before you watch today's lesson, Lesson 2, you should go back and make sure you have watched Lesson 1 and completed the Lesson 1 assignment. As we're getting up and running on Google Classroom, if you missed Lesson 1, I don't want you to start here. I want you to go back and do Lesson 1 and the assignment, even if it's past the deadline, and then come on back here and watch Lesson 2. So if you need to, pause the video, go do Lesson 1 and come on back. If you are all caught up, you've done the Lesson 1 assignment and left me a lesson summary in the comments, then you are in exactly the right spot. Happy Tuesday. You need a couple of things before we get started. You should have paper and a pencil, just like yesterday. You should also be in a space that is distraction-free as much as possible. So if you have a phone, go ahead and make sure it's on Do Not Disturb for the duration of class. If there's a TV in the room that you're in, make sure it's flipped off and you have a quiet space where you can focus. Okay. Go ahead and let's get our notes set up. Go ahead and do this with me. This is Unit 7. Lesson 2, and what we're working on today is points on a number line. I'm using a lot of number lines today to talk about our negative and positive numbers. Points on a number line. And today I'm going to put the date in the corner. Today is March 31st, 2020. All right, so notes are set up. We've got a few things to do together, and then I'm really excited to release you to do some work on your own as well. Okay, so our goals today include representing positive and negative numbers, including what are called opposite numbers on a number line. Really excited to get into that today. We'll define what opposite numbers is by the end of class as well. All right, take a look at my document, because here are 5 thermometers. Remember, thermometer measures temperature. The first 4 thermometers show temperatures in Celsius. Write the temperatures in the blanks. It says down here, the last thermometer is missing some numbers. Write them in the boxes. So we'll actually spend most of our time together talking about thermometer D and E because it gets into some interesting negative numbers on a number line stuff. But A, B, and C should be really quick to do on your own. So I'm going to just set a timer for about 1.5 minutes. What I want you to do is start labeling what the temperature is for A, B, and C. If you have extra time, go ahead and move on to D and E. Your paper should look like this. Probably for most of these, you don't need to draw the thermometer, but go ahead and label 1A and then write what the temperature is. Same thing for B, write what the temperature is. Okay? 1.5 minutes are on the clock. You should get started. We are halfway through our time, about 40 seconds left. All right, there is our time. Okay, hopefully you had enough time to answer at least A through C. If you didn't, pause the video and feel free to take a little bit of extra time. Here's what I thought for those first few number lines. So I found that A was at 1 degree Celsius. If you got that, you can give yourself a little self 5. Crushed it. 1B, that thermometer I found was at negative 2 degrees Celsius. Great job using a number line to identify negative numbers. C, I found 3.5 degrees Celsius. And I want to say why. In between 3 and 4, about halfway is 3.5. So, and this isn't positive. So that should be 3.5 degrees Celsius. If you wrote 3.5 or 3 5/10, that works as well. D is interesting. I love this one because it's negative. This temperature is between 0 and negative 1. Between 0 and negative 1. So I know that temperature is going to be negative. It's less than 0. And it looks like it's about halfway in between. So this temperature is actually negative 1/2 degrees Celsius or negative 0.5 degrees Celsius. Go ahead and make sure you have these 4 correct answers on your paper. And if you're not sure where one of these came from and my explanation wasn't clear, make sure you leave a comment and I'll be able to get back to you. Awesome. Let's talk about E. I actually want to go ahead and draw this number line on our paper for E. Okay, so let me see if I can get both up here. Oh yeah. Awesome. All right, so where I have a little bit of extra space, I'm going to go ahead and draw in the thermometer for E. So I'm going to be using a vertical number line, and I know it's going to be going from a maximum of 25 all the way down to a minimum of negative 20. And I actually want to fill in all of those numbers. The reason I'm doing this is really to help me understand where negative numbers go on a number line and how to order negative numbers. Okay, so go ahead and draw this with me. I'm going to start at the top. Because I have graph paper, I'm just going to use every box as a tick mark. If you have lined paper, this works too. If you have just blank paper, no lines, that's okay. Just do your best to make those tick marks even. I'm going to start at positive 25, and then there's a blank, and then there's another blank, and then there's 10. I know on a number line when I have these equally spaced tick marks, that means that each one has the same amount. So I have to figure out basically what am I counting by in order to skip 2 and then get to 25. Okay. It doesn't look like 1. If it were 1, that would be 11, 12, 25. That doesn't make sense. This should be plus 5 every time. So 15 and 20 and 25. So each time plus 5 as I move up. As I go down, of course, subtract 5. So let's practice our integer subtraction. Below 10, 5 below 10 is 5. 5 below 5 is, did you say 0? Good, you're already adding opposite numbers. Nicely done. And then 5 below 0, this one was given to us, is negative 5. Negative 10. Negative 15, and negative 20. All right, so there's my thermometer with all of the numbers filled in. Now I keep saying thermometer, this is actually a vertical number line. The reason we're talking about temperature in class today is because it's really good for using, it's a really good analogy for a vertical number line to look at a thermometer. All right, so this temperature E reads all the way down here at negative 20. So I'm going to go ahead and just plot a point at negative 20. That's the measure of the thermometer. E is at negative 20 degrees Celsius. Very cold. Awesome. Make sure your paper is updated. This is a good reference for you later on to have that number line on your paper. Okay. Awesome. Let's try another one. All right, for this activity, this says folded number lines. Because we are not in class together, I can't give you tracing paper to fold, but we are going to draw a number line together. So actually, before we get into any of these questions, we're going to draw this time a horizontal or side-to-side number line that goes from -10 to +10. Okay. So I'm going to just skip a line on my paper and label this question 2. I'm going to give myself plenty of space to do this because I'm going to be using this number line to answer some questions. So I'm going to leave some space above, some space below, and some space on the sides. But I do want to make sure I go from -10 to +10. Okay. I am going to start with 0 about in the middle. And then my positive numbers we know are on the right. So I'm going to go ahead and count up all the way until I get to 10. Let me see if I can use one box for every number. Perfect. I'm going to use every box for one number. If you don't have graph paper, that's totally fine. Just make your tick marks equally spaced as well as you can, and make sure you go all the way to +10. Okay, go ahead and do that now. So 2 important things to notice. One is that these are all positive numbers, and also that these are to the right of 0. Awesome. And then we can go ahead and look at the negative numbers. So again, I'm going to use one box on my graph paper for one unit. 1 less than 0 is -1. 1 less than -1 is -2. -3. I'm going to keep going like that all the way until I get to -10. All right, take a second, make sure your paper looks like mine. We're going to use this number line in a few different questions coming up. So if you need more time, please click pause. Otherwise, let's move on. All right, number 2 says, use your number line to answer these questions. A, which number is the same distance away from 0 as is the number 4? I'm going to read it one more time. Which number is the same distance away from 0 as is the number 4? Let's take a look at our number line and find number 4. Go ahead and plot a point on 4. How far away is this point from 0? Hopefully you said it is 4 away from 0. I can tell that if I count the spaces. Remember, not the tick marks, the spaces. So 1, 2, 3, 4. It's 4 spaces away from 0. Okay. This question said, which number is the same distance away from 0 as is the number 4? So I see that the number 4 is 4 spaces to the right of 0. So if I want to find another number that's that same distance away from 0, I'm actually going to move to the left. So I'm going to start at 0 and go 4 spaces to the left. 1, 2, 3, 4. I land on -4. So this question, A, asks me what number was the same distance away from 0 as 4? I know that the number -4 is the same distance away from 0 as 4. Okay. I'm going to show this in one more way. Go ahead and update your paper. This distance from 0 to 4 is 4. Remember, we said distance is always positive. And this distance from -4 to 0 is also 4. There's 4 spaces. That's how I know my answer is true. So let's go ahead and write an answer for A. The question said, which number is the same distance away from 0 as is the number 4? So to answer that question, I'm going to say -4 is the same distance away from 0 as is 4, or +4. -4 is the same distance away from 0 as is 4. Awesome. Let's look at the next one. Which number is the same distance away from 0 as is the number 7? Okay, let's just take 30 seconds and see if you can do this one on your own, and we'll come back together. Go. All right, there's our time. Didn't quite finish, but I got close. Here's what I was thinking. I went ahead and put a triangle on -7 as my starting point. I just changed the shapes to help me see the second problem. I can use the same number line if I kind of use a different kind of point. So the distance I found between -7 and 0 was 7. So if I'm looking for a number that has the same distance from 0, I'm going to look in the positives. I'm going to look to the right of 0. And I see that the number that is 7 spaces away from 0 is 7. So there are two numbers that are 7 spaces away from 0, -7 and 7. So I was writing, and you should pick up with me, 7 is the same distance away from 0 as is -7. Oops, sorry guys. 7 is the same distance away from 0 as is -7. All right, if you need more time, click pause. If you're ready to move on, I'm going to label my paper and get ready for part C. Here we go. Definition time. Two numbers that are the same distance from 0 on the number line are called opposites. Wow, that's important. I'm going to read it one more time. Two numbers that are the same distance from 0 on the number line are called opposites. Find another pair of opposites on the number line. So for example, the numbers -4 and 4 are opposites. They are, did you say it out loud? Is it weird? Cool. The numbers -7 and 7 are opposites. That's because they are the same distance from 0. Can you come up with another pair of opposite numbers? Take 10 seconds, write it down for C. All right, I will give you another example. The number -9 and the number 9 are opposite numbers. Or you can just say they're opposites. Oops. You could have said any pair of numbers that were the same distance from 0. So 1 and -1, or 6 and -6, for example. One thing that's interesting here, before we move on, is I made an integer number line. So a number line with the whole numbers and their opposites, so the negative whole numbers. But there are other numbers on this number line that I didn't label. There are so many other numbers on this number line that I didn't label. Like, let me put a star here at 5.5. Does 5.5 have an opposite? It does. What is the opposite of 5.5? Did you get it? -5.5. Go ahead and put a star at -5.5. Careful, it should be between -5 and -6. The same way that +5.5 is between +5 and +6. That's cool. We use mixed numbers to find opposite, or we found opposite numbers with mixed numbers. Really cool. Let's write that example also for number C, for letter C. Go ahead and write that with me. So 5.5 and -5.5 are opposites. Can you think of another one that's spicy, like 5.5 and -5.5? If you do, think of another one that is interesting or you think I would like in your lesson summary at the end. When you leave me a comment, go ahead and include that in your lesson summary. What are the opposite numbers that you chose? I would love to see some decimals in those comments. All right, let's get our paper set up for part D. Here we go. Part D says, determine how far away the number 5 is from 0. Okay. Then choose a positive number and a negative number that is each farther away from 0 than is the number 5. Let me read that one more time. Determine how far away the number 5 is from 0. Then choose a positive number and a negative number that is each farther away from 0 than is the number 5. All right, so let's take a look at the number line. Here is the number 5. I'm going to put a box on number 5. How far is it from 0 to 5? Did you say 5? It is 5 units away, right? So now I want to find, let's start with a positive number. Can you tell me a positive number that is farther away from 0 than 5 is? If you said 5.5, or if you said 6, 7, 8, 9, 10, if you said 85, all of those are positive numbers that are farther away from 0 than 5 is. If you said 2, that's incorrect because that's actually closer to 0 than 5 is. Okay, so I'm going to write the number 7. 7 is a positive number that's farther from 0 than 5. 7 is farther. You can pick 7 or you can pick your idea. From 0 than 5. Sweet. This question also asked us to find a negative number that was farther away from 0 than 5 was. So let's look at that. Can you think of a number, maybe a couple of examples, that are farther away from 0 than 5 is? I know that 5 spaces away from 0 would get me to -5. So if you picked anything that is more negative than -5, then you are correct. So if you picked -6 or -7 or -8 or -8 and 2/3 or -9 or -100, those are all numbers that are farther away from 0 than 5 is. I'm going to use -10. -10 is farther, and again, you can use my example or your own, is farther from 0 than 5. Alrighty, last question, team. E. Determine how far away the number -2 is from 0. Okay. Then choose a positive number and a negative number that is each farther away from 0 than the number -2. Okay, so same style of question, just instead of 5, we're starting with -2. No problem. Let's go ahead. I'm running out of shapes to put on my number line. I'll put another dot. That's fine. Maybe I won't shade it in this time. All right, here is -2. How far away is -2 from 0? It is 1, 2 spaces away from 0. So go ahead and list one positive number and one negative number that is farther away from 0. I'm going to do it with you, but I'm going to hide my paper for just a minute as we get this going. So this should probably be about 30 seconds. Give me one positive number and one negative number that are each farther away from -2 on the number line. All right, team, here's what I thought. If you need more time, please click pause. I picked the numbers -4 and the number 12, even though that one's not on my number line. These numbers are each farther away from 0 than -2 is. -4 is more negative than -2, and 12 is much farther away than 2 spaces. It's 12 spaces away from 0. There we have it. So today, what have we done? We have looked at points on a number line. We have looked at temperatures, including some temperatures that fell between those integers, so like -1/2. We have looked at filling in the gaps on a number line, including into our negative numbers. And we have studied opposite numbers, especially on a number line. We know that opposite numbers are two numbers that are the same distance from 0 on either side of 0, like -4 and 4 are opposites, or -3.5 and +3.5 are opposites. We have also we've started comparing distance from 0. So for example, 7 is farther away from 0 than -2 is. Okay. In your independent practice today, you're going to be asked about what is an opposite number or state the opposite number. So if I say, what's the opposite of -9? You would say, well, -9 is 9 spaces away from 0. I know that +9 is also 9 spaces away from 0. So +9 is its opposite. Okay. Sweet. Before we move forward, I want to just take a couple of really important notes and review kind of a summary of today's lesson. So here we go. Here is a numbering line labeled with positive and negative numbers. The number 4 is positive, so its location is 4 units to the right, positive to the right, to the of 0 on the number line. The number -1.1 is negative, so its location is 1.1 units to the left. Negative is to the left, to the of 0 on the number line. We say that the opposite, we talked about that word a lot today, of 8.3 is -8.3, and that the opposite of, this is -3/2, the opposite of -3/2 is 3/2. Any pair of numbers that are equally far away from 0 are called opposites. One thing to note here, do you think 0 has an opposite? Interesting to think about, right? If you were asked what's the opposite of 0, I would say either there's no opposite, or you can say 0 is the opposite of 0. 0 is 0 spaces away from 0. So having an opposite number for 0 doesn't make as much sense. All right, points A and B are opposites because, A and B, look at these on the number line. This one, B, is between 2 and 3, and this one, A, is between -2 and -3. Points A and B are opposites because they are both 2.5, 2.5 units away from 0, even though A is to the left and B is to the right of 0. A positive number, you probably already noticed this pattern, has a negative number for its opposite. A negative number has a positive number for its opposite. The opposite of 0 is itself. We won't use that as much when we're talking about opposites. It's kind of a special case. You have worked with positive numbers for many years, that is true. Of all of the positive numbers you have seen, whole and non-whole numbers can be thought of as fractions and can be located on a number line. To locate a non-whole number on the number line, we can divide the distance between two whole numbers into fractional parts and then count the number of parts. For example, 2 and 7/10, 2.7, can be written as 2 and 7/10, mixed number style. The segment between 2 and 3 can be partitioned or split into 10 equal parts, or 10 tenths. From 2, we can count 7 of the tenths to locate 2 and 7/10 on the number line. Okay. So just all that's saying is that if I want to make a number that's not an integer on an integer number line, no matter if it's positive or negative, I use the same strategies that I've been using since elementary school to break that number or partition that number into pieces. So if I want 2.5, then I split between 2 and 3 into half, right? And I count from 2 to 2.5. I can do the same thing with negative numbers. It's just flopped. So if I want to go more negative than -2, if I want to go 1/2 more negative, then I'm moving to the left. All of the fractions and their opposites are what we call rational numbers. This is another good vocab word. For example, here are all the numbers you can use on your number line. 4, negative 1.1, negative 8 and 3/10, 8 and 3/10, negative 3/2 and 3/2. Any fraction, decimal, or whole number, positive or negative, is called a rational number. Here are a couple of notes, glossary terms. We're going to skip writing down rational number for now, but I do want to make sure we have opposite in our notes. So go ahead and find your notes. I'm just going to flip to the back here. And let's go ahead and write down the definition for opposite numbers. Two numbers are opposites if they are the same distance from zero and on different sides of the number line. And then here's an example. For example, 4 is the opposite of negative 4, and negative 4 is the opposite of 4. They are both the same distance from zero. One is negative and the other is positive. Okay, I'm going to copy this first sentence exactly. Go ahead and do that with me. If you need more time, go ahead and pause the video. Your note should say opposite. Two numbers are opposites if they are the same distance from zero and on different sides of the number line. Give one example. Negative 4 and 4. We have lots of examples in our notes, so we're going to pause there. Actually, let's do just one for fun. Why not? 1 and 1/10 and negative 1 and 1/10. Those are opposites, even though they're decimals, and I like them more because they're decimals. Awesome. All right, team, we are finished with notes. So here's just a couple of reminders about what's coming. You have your independent practice that's in this post, so make sure you go complete that independent practice. If you would like some help on that, independent practice, then make sure you hop on to office hours with Mr. Zamora at 3:15 by clicking the link that can be found in your Google Classroom. If you missed that office hours and you want some more help, please feel free to text Mr. Zamora or myself between 8 a.m. and 8 p.m. If you need help outside of those times, just do your best on your own and wait until the following morning. And we'll be happy to help you at those times. And just also as a reminder, reteach will happen tomorrow, April 1st at 10:45 a.m. So make sure you log on to Google Classroom at around 10 to see if you're invited. And if you're not invited, but you do want to go, then just send Mr. Zamora a text. I'm sure he'd be happy to include you. So 2 things you need to do. 1, complete the independent practice linked on this assignment. 2, write a lesson summary. So 1 to 2 sentences that summarizes what we did in this lesson and what you did in independent practice, and leave that as a comment. I have loved reading your lesson summaries so far. All right, team, that's it. We nailed it. Go ahead and enjoy the rest of your day. Have a great independent practice. And do my TED Talk. Bye, guys.